We're going to walk through how to evaluate 7 indefinite integral examples using U-substitution. To make things easier, I've listed 5 steps that we can follow, and we'll go through these steps one by one as we work through each example. Let's start with our first example. We are going to integrate 2x times the square root of 1 plus x squared. The first step is to choose u. We are going to choose u to be the function whose derivative occurs in the integrand. So we're going to let u be equal to 1 plus x squared. Our second step is to calculate du and then solve for dx. Du is equal to 2x dx, and we get that dx is equal to du all divided by 2x. The next step is to substitute this back into our integrand and rewrite the integral in terms of u. We have the integral of 2x times the square root of 1 plus x squared, which is now u, times dx, which is now du divided by 2x. Notice that the 2x's cancel, and that's because we made a good choice for u. And this is the integral of u to the 1/2 du. I'm writing it like that because it's going to make it easier to integrate. Step 4 is to just integrate this new integral. We have the integral of u to the 1/2 du, and that is equal to u to the 3/2. You just add 1 to your exponent, and then we divide by 3/2, and then we add our plus c. And let's rewrite this as 2/3 u to the 3/2 plus c. Our last step is to just rewrite our answer in terms of x. This gives us the answer 2/3 u, which is 1 plus x squared, to the 3/2 plus c. And there's our answer. Let's now look at our second example. This is a little bit more complicated than the first one. We are integrating x squared times the quantity x cubed plus 5 raised to the 6th power. We're going to start by choosing u. I'm going to let u be equal to x cubed plus 5 because the derivative is 3x squared, and we have an x squared in our integral. U is equal to x cubed plus 5. And then our second step is to calculate du and solve for dx. Du is 3x squared dx. And this means that dx is equal to du all divided by 3x squared. Now let's go ahead and let's substitute dx and u back up into our integral. We have the integral x squared. Now we're going to have u raised to the 6th power times dx, which is now du, all divided by 3x squared. We're going to cancel out our x squared terms, and we're left with 1/3. We can bring that out in front of the integral, u to the 6th du. Our fourth step is to just integrate this new integral. We have 1/3 the integral u to the 6th du is equal to 1/3. We're going to add 1 to the exponent, so we have u to the 7th divided by 7 plus c, and then we'll combine our constants, and we have 1 over 21 u to the 7th plus c. Our last step now is to rewrite this in terms of x, and our answer is 1 over 21. For u, we substitute back in x cubed plus 5, raise it to the 7th power, and then add c. And there's our answer. Let's look at our third example. This is an example where we're going to use what's called back substitution, and I'll show you exactly how that works. Notice with this integral that we don't have a function whose derivative is in our integral. That means what we're going to have to do is choose u to be the more complicated part of the integral, and that is going to be x cubed plus 1. So we're going to let u be x cubed plus 1. Our second step then is to calculate du and solve for dx. Du is 3x squared dx, and that gives us that dx is du all divided by 3x squared. Now let's substitute u and dx back up into our integral. We have the integral of the cube root of u, and then we have an x to the fifth. We'll do something with that in a minute. And then we have dx, which is du all divided by 3x squared. Now we're going to simplify this. We can bring a 1/3 out in front, and notice that our x squared is going to cancel with our x to the fifth, and we'll end up with an x cubed. We have the integral of the cube root of u, and we're going to write this as u to the 1/3, and then we have an x cubed and a du. Here's where back substitution comes in. Notice that our integral has a u cubed in it, but if we go back up to step 1, we can see that we can write u cubed in terms of u. We have u equal to x cubed plus 1, so x cubed is u minus 1. That's called back substitution. Let's see what this gives us. We have 1/3 times the integral u to the 1/3 times x cubed, which we just found was u minus 1, du. Now we can go on to step 4 and do the integration. We have 1/3 the integral u to the 1/3 times u minus 1. With this integral, we have two functions that are multiplied, u to the 1/3 and u minus 1, and the way that we can integrate this is by multiplying those two functions out. So let's go ahead and let's do that. This gives us 1/3 the integral u to the 1/3 times u is u to the 4/3, and then we subtract u to the 1/3 du. And we can go ahead and integrate this. This is 1/3. U to the 4/3 is u to the 4/3 plus 1, which is 7/3. And we divide by 7/3. And then we subtract u to the 1/3 plus 1 is 4/3. And we divide by 4/3. And then we have our plus c. Let's simplify this by bringing the fractions that are in the denominator up to the numerator. Our first term is 3 over 7, u to the 7/3, minus 3 over 4, u to the 4/3, plus c. And notice that our 3's are going to cancel. And this leaves us with 1/7 u to the 7/3 minus 1/4 u to the 4/3 plus c. Now for our last step, all we have to do is rewrite our answer in terms of x. Our answer is then 1/7. Instead of u, we have x cubed plus 1, and we raise that to the 7/3, and then we subtract 1/4, and we have x cubed plus 1 raised to the 4/3 plus c. And there's our answer. Let's now look at our fourth example. This example has an exponential function in it. We know that the integral of e to the x dx is just e to the x plus c, but we don't have a formula for the integral of e to a constant times x. So what we're going to do is use U-substitution, and we're going to let u be equal to 2x. Now we can go ahead and find du. du is just 2 dx, and this gives us that dx is equal to du divided by 2. Now we're going to substitute u and dx back up into our integral. This gives us the integral of e to the u times dx, which is du divided by 2. We can go ahead and integrate this. The integral of e to the u is just e to the u. So we have 1/2 e to the u plus c. And then our last step is to just replace u with our function of x. And we get an answer of 1/2 e to the 2x plus c. And there's our answer. Using this example, we can now write down a formula for e to the a times x dx. This is just going to be 1 over a e to the ax plus c. That looks really similar to when we took the derivative of e to the ax and got a times e to the ax. So when you take a derivative, you multiply by a, but when you integrate, you divide by a. Let's now look at example 5. This is one of 3 examples where we're going to be integrating trig functions. In this example, notice that we have the function 1 plus tangent theta, and the derivative of that is secant squared theta, and that is up in the integrand. That tells us that we can let u be equal to 1 plus tangent theta. Our second step then is to find du. du is secant squared theta d theta, and we need to solve for d theta, so we can substitute it back up into our integrand. It is du all divided by secant squared theta. Let's now substitute everything back up into our integral. We have the integral of 1 plus tangent theta, which is now u. So we have u to the 5th. We have secant squared theta. And now for d theta, we have du all divided by secant squared theta. Because we made the right choice of u, those functions are going to cancel. And we just have the integral of u to the 5th du. In step 4, we can go ahead and integrate the function. This is going to give us u to the 6 over 6 plus c. And then for step 5, all we do is substitute back in what u is equal to. So we have an answer of 1 plus tangent theta raised to the 6th power, all divided by 6 plus c. And there's our answer. Once you get used to using U-substitution, you can probably just write down the answer and not even have to go through all these steps. Let's now look at example 6. This one is a lot more complicated than our last example because it's not clear at all what to let u be equal to. I think the best way to find out what we should set u equal to is to notice that we have 2 functions that we're integrating. We have a secant function and a tangent function. So let's go ahead and let's write down what the derivative of these 2 functions are, and that will help us figure out what we should let u be equal to. The derivative with respect to x of secant x is secant x tangent x, and the derivative with respect to x of tangent x is secant squared x. If we let u be equal to secant x, then we have the derivative up in our integrand without anything left over. If we let u be equal to tangent x, we have the secant squared, but then we have a secant cubed left over, and we're not going to know what to do with that. So that's why letting u equal secant x is the right choice for this problem. For step 2, we are going to find du. Du is equal to the derivative of secant, which is secant x tangent x, dx. Now we can solve for dx, and we get du all divided by secant x tangent x. When we're doing a substitution like this that's complicated, in step 3, we want to start by just substituting back in dx. This gives us the integral secant to the 5th x times tangent x times dx, which is now du, all divided by secant x tangent x. Notice that tangent x is going to cancel, and then secant is also going to cancel and give us secant to the 4th x. Now, we can simplify this and let u be equal to secant x. So this gives us u to the 4th du. Now we can go ahead and integrate this. The integral of u to the 4th du is going to be u to the 5th all over 5 plus c. And then for step 5, all we have to do is replace u with secant x. This gives us an answer of 1/5 secant to the 5th x plus c. And there's our answer. Let's look at our last indefinite integral example. I wanted to include this because this is a tricky one, and as soon as you see how to do it, you'll remember exactly what to do. For this problem, it is not clear at the beginning what we should set u equal to, because we only have one function that we are integrating. When you only have one function that you're integrating, and you don't have a formula for the integral of that function, what you need to do is change that function. So let's think, what can we change tangent to? The best thing is to change it to its definition. So let's do that. The integral of tangent x dx is equal to the integral of sine x all divided by cosine x dx. Now we have two functions, and we can pick one to be u. We want to choose u to be the function whose derivative is in the integral. So we're going to let u be equal to cosine x, because the derivative of cosine is minus sine, and that is sitting up in our numerator. Our second step is to calculate du. Du is minus sine x dx. So dx is minus du all divided by sine x. Now let's go ahead and substitute this into our integral. We have sine x all divided by cosine x times dx, which is minus du all divided by sine x. This is minus the integral, canceling out our sine functions. We have 1 over cosine x times du, and our u is cosine x, so this is just minus the integral of 1 over u du. Now we can go ahead and integrate that. The integral of minus 1 over u du is equal to minus the natural log of absolute value of u plus c. We can't forget to put the absolute value there. Now we can write down our answer by substituting back that u is cosine x, and this gives us minus natural log absolute value cosine x plus c. That answer is okay, but it's not the best way to write it because we have a minus in front of our natural log. So what we're going to do is we're going to take that minus up into our function. That's a property of natural logs that makes us able to do that. So we're going to write this as natural log absolute value cosine x to the minus 1 plus c. And we know that 1 over cosine x is secant x. So we can write our final answer as the natural log of the absolute value of secant x plus c. And that's the standard way to write this integral. You might want to add this to your list of integrals. We found that the integral of tangent x dx was the natural log of the absolute value secant x plus c.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.